Hi folks, Mr. Long here. I'm doing a screencast about BEDMAS graphing of parabolas, or quadratic functions as we call them. So what we want to do is graph this function y equals negative 3 x squared plus 1. And we want to do it with order of operations, brackets, exponents, division, multiplication, addition, subtraction. And you have to remember that these are grouped together, right? So division and multiplication in the order that you see them. There is no, you don't have to do division before multiplication or multiplication before division. So if you look at this question, there doesn't appear to be any brackets. So what we really need to do, or if you see this equation, we need to introduce some brackets. And what we do is we bracket the x. So it's negative 3, and then bracket the x, square it, and then add 1. So the first thing we need to do is brackets. And the way we do that, we look at the brackets and we say that that's equal to x. Okay, so we start by graphing y equals x. And here's what it looks like. Y equals x is, I can think of it this way, it's x plus 0, which means the y-intercept is 0, and it has a positive slope of 1 over 1. So it looks like that. That's y equals x. And the next thing I do in terms of BEDMAS, of course, is, the next thing I do in BEDMAS is I need to square something. And the way I square it, or what I do is, in terms of squaring it, is, so that's the exponent, e, and we want to do some squaring. So I just put brackets squared. Brackets squared. And so let's take a look. What will that look like? And I'm just going to show it over here so we can see it. So the main idea here is that I'm squaring all of these y values. So these are all positive y values. That's 0. I'm going to square 0 there, and then I'm going to square a bunch of negatives down here. So when I square negatives that become positive, the minimum square occurs at 0, which is, as you can see, right at the origin. So let's go ahead and do that. So when I square it, it looks like that, right? That's not that great, but it's at 0, 0, because when I square 0, I get 0. And remember that all of those negatives that were right here become positive here, because a negative times a negative is a positive. So we have this characteristic parabola. So now I've squared it. If we look at back at our equation, whoa, that wasn't very good, was it? If we look back at our equation, we have done brackets, we've done exponents. Next thing is division multiplication, which occurs right here. I'm going to multiply that by negative 3. So all the y values are being multiplied by negative 3. Okay, so let's go down here and see what we've got. So I've got to take all of those values. So let's maybe write this down. I need to multiply by negative 3. Okay, so I'm multiplying all of those y values. So if I look, and I'll pick a y value. Maybe I've picked a y value of 9, right? So there's a y value of 9. Or make it 10 to make it easier, right? Let me just erase that, just to make it really, really simple. Make that 10. So I'm multiplying by negative 3 y values, only the y values. So 10 times negative 3 is negative 30. So if I look, this right here is where it's equal to 10, say. It's just a rough sketch. It doesn't really matter how I look like it, what it looks like. It's a rough sketch, right? So I'm multiplying that y value right there, which I'm saying is approximately 10, and I multiply it by negative 3. That's going to become negative 30. Over here, I'm multiplying that y value by negative 3. That's going to become negative 30. The y value at the vertex is 0, and I multiply that by negative 3. 0 times negative 3 is still 0. So what this does is it reflects the parabola, because I'm multiplying by a negative. So it will now look like this, but it'll be much steeper because all the y values have been multiplied by by negative 3. So where it used to be out here, it used to be some number, well, which would be like 3.2 and 10, it would now be 3.2 and negative 30. So it's just much steeper and reflected. The very last thing, well, if I go back up, What's the last thing in this equation? Well, now I'm doing addition and subtraction, right? So there's the last thing I do, the plus 1. Okay, so I'm going to do plus 1. Well, let's get that done. That's the very, well, somehow I rotated that. There we go. So now I need to do adding of plus 1. So we're going to add plus 1 in terms of our BEDMAS, and that finishes it off. So that's adding plus 1 to all of the y values. Well, the only thing I'm really going to see a difference there is the vertex, because that's the only way to move the vertex, is to add or subtract. So right now the vertex is at 0, 0. That just means it's going to move up right here to y equals 1. Okay, and all the other y values will have lifted up as well by 1, but that's the only noticeable difference. And by the way, it doesn't look like, I didn't draw a very good sketch there. That should be the vertex. So, okay folks, so that's what you do. Now you're done. And in this case, the vertex is at 0, 1, which is also the y-intercept. Okay, and that's how you do that. I will do another example on a later screencast. Have a great day. Hi folks, Mr. Long here again. I'm going to do another example for you for graphing by BEDMAS. So what you can do actually, I didn't do it last time, but you can sort of work through everything and write it out first. So if I look here, the brackets would equal x plus 3. Exponents for BEDMAS is squaring. There's no multiplication or division, and then there's subtracting of minus 4. Okay, so those are your three operations, and we do it in order, right? We do x plus 3 first. Once we have x plus 3, then we square it. And finally, what we do is subtract 4. So I'm going to go through this one quite a bit quicker than that first example. So let's go ahead and do this. So the first one is to do brackets, which is x plus 3. Well, for x plus 3, I know the y-intercept is 3. And it's a 1 over 1 slope, and it's positive, so that's at negative 3. There's our brackets. So now I've graphed that straight line. The next thing I need to do is to square it. Okay, I'm squaring the line now. I've got x plus 3, now I need to square the line. Remember that x plus 3 represents a y value, right? X plus 3 is a y value. So what am I squaring? X plus 3. So I'm squaring the y values. So I've got to square that 3. It's a y value, so it's going to become 9. It's going to move up. What's that value right there, the y value? Well, the x-intercept, the y value is 0. If I square 0, I get 0. Right? That's the 0 square. So the 0 square exists at x equals negative 3. All of these values I'm going to square as well. Now when I square a negative, I get a positive. Okay, so all I'm going to worry about, though, is the vertex and that y-intercept. Okay, so let's go through this. I'm going to move down a little bit here and do the next one. So I should probably highlight that. The one in brackets there. Okay, so that's brackets. The next thing going down we said is exponents. And that is squaring. And so now what we're going to do here is, I've got this graph right there. I'll put this graph right here, negative 3, and just to remember that, I'm squaring all of the y values. So I'm going to square that y value right there of 3. So when I square that y value of 3, I get 9. There's our new y-intercept. Okay, it's up here at 9. When I square at the when I square at the x-intercept, I'm squaring the y value, which is 0. It doesn't change. Okay, so it looks like that. We know the characteristic shape. And on the other side, as I square this part right here, those negatives, negative times negative is a positive, and I get this characteristic parabola or parabola, okay, with a y-intercept of 9. Okay, we've got that. So now we've squared. Sorry, we started by brackets, then we did squaring, and now the last thing is to subtract 4 from all of the y values. So I have to take this graph, the last one, and I'm going to subtract. The subtraction is going to be minus 4. The subtraction is minus 4. So that's from all the y values. So I'm going to have to minus 4 from that 9. Well, what will that become? 9 minus 4 is 5. Let me draw a set of axes, like so. So now it's going to be through 5. And what about the vertex? The y value there is 0. I have to subtract 4 off that, so it's going to be down at minus 4. Of course, it's still at an x value of minus 3 because I'm not affecting the x values. Operations are not applied to x. Operations are applied to y values. Okay, so let's draw our sketch now. So I know that this is the vertex down here, and that's the y-intercept. So it will look like this. Okay, so that's our new graph. That's the fully transformed graph. Y equals x plus 3 quantity squared minus 4. Okay, and that is your parabola. And you just have to maybe make note of the vertex being at negative 3, comma, negative 4, and your y-intercept is at 5. Okay, hopefully that helped, guys, and have yourself a great day or night.